Imagine this: a lone wanderer from the depths of another star system, hurtling through the void of space at speeds that defy our wildest dreams, over 130,000 miles per hour, barreling straight into our solar backyard. It's not a meteor, not an asteroid from our own cosmic neighborhood, but an honest-to-goodness interstellar visitor, the third one we've ever spotted discovered on July 1st, 2025, by the sharp-eyed Atlas Survey Telescope in Chile. This enigmatic object, dubbed 3I/ATLAS, has astronomers, scientists, and stargazers alike glued to their screens, telescopes, and feeds. And as of November 14th, 2025, just 2 weeks before its closest swing by Earth on December 19th, the plot has thickened in ways that could rewrite our understanding of the universe. Non-gravitational accelerations, a bizarre blue glow, and hints of massive mass loss that might, or might not, reveal a tale of cosmic fireworks. Is it a natural comet shedding its icy skin under the sun's relentless heat? Or could it be something engineered, a relic from an alien civilization probing our world? Stick with me through this deep dive, because by the end, you'll not only grasp the science, but feel the pulse-pounding thrill of discovery that's unfolding right now. And trust me, the revelations from the latest data will leave you staring at the night sky with new wonder. Let's set the stage properly. Our solar system isn't the isolated bubble we once thought it was. Since 2017, when the first interstellar interloper, 1I/Oumuamua, streaked through like a cosmic cigar, we've realized these visitors are more common than we imagined, yet still rarer than an honest politician. Oumuamua, that elongated mystery about the size of a football field, puzzled us with its tumbling motion, extreme shape, 10 times longer than wide, and a subtle acceleration that couldn't be explained by gravity alone. Harvard astrophysicist Avi Loeb famously suggested it might be an alien light sail, a thin, reflective probe pushed by sunlight. Skeptics rolled their eyes, but the debate sparked a revolution in how we hunt for extraterrestrial tech. Then came 2I/Borisov in 2019, a more familiar comet with a bright nucleus and a gassy tail, reminding us that not all visitors are weirdos. Some are just frozen snowballs from afar, rich in carbon monoxide and hydrogen cyanide, offering a peek at chemistry from another star. Enter 3I/ATLAS, the third act in this interstellar trilogy, and it's stealing the show. Spotted initially as a faint smudge in pre-discovery images from June 14th, 2025, courtesy of the Vera C. Rubin Observatory's science validation runs, this beast is no lightweight. Early estimates peg its nucleus at up to 20 kilometers across, making it 1,000 to 100,000 times more massive than Oumuamua or Borisov. That's city block size, folks, a colossal drifter estimated to weigh over 33 billion tons, with a density suggesting a rocky, icy core tougher than your average comet, its trajectory. Hyperbolic to the extreme, with an eccentricity of 6.2, screaming interstellar, louder than a supernova. Unlike Oumuamua's modest 1.2 eccentricity, or Borisov's 3.6, 3I/ATLAS is on a one-way ticket out of here, slingshotting around the sun at perihelion on October 29th to 30th, 2025, just inside Mars's orbit at 1.4 astronomical units, about 130 million miles. No collision course for Earth. Phew. Its closest approach to us is a safe 1.8 astronomical units, 167 to 170 million miles, on December 19th. But safe doesn't mean boring. As it dove toward the sun, telescopes worldwide watched it brighten dramatically, scaling inversely with distance to the power of -7.5, and shift to an eerie blue hue, bluer than the sun itself. Dust should make it redder. This blue screams ionized carbon monoxide or something else. What hooked me, and I suspect you, over this past weekend, was the frenzy of updates flooding in. If you, like me, found yourself hitting refresh on NASA's site, Avi Loeb's Medium blog, or X feeds from observatories, you're not alone. The hype train left the station weeks ago, fueled by headlines screaming alien engine detected, or comet turns blue, what's hiding inside? But let's pump the brakes and dive into the real science, because amid the clickbait, there's gold. Last week, reports trickled in about 3I/ATLAS getting brighter and bluer as it neared the sun now. As of early November 2025, NASA's Jet Propulsion Laboratory, JPL, has dropped a bombshell, evidence of non-gravitational acceleration in plain English. This thing is speeding up, or deviating, thanks to forces beyond gravity's pull. Data from the Atacama Large Millimeter Submillimeter Array ALMA Observatory clocked a 4 arcsecond shift in right ascension from its predicted path on October 29th. That's statistically huge, like missing your highway exit by a mile. To unpack this, we need to channel the wisdom of one of the sharpest minds in astrophysics, Harvard's Avi Loeb, back for another round of myth-busting and mind-expanding Professor Loeb, whose book, Interstellar, just hit paperback in August 2024, has been our guide through these cosmic riddles since Oumuamua. In a recent interview on News Nation, he laid it out. "Thanks for having me. Always a thrill to chase these ghosts from the stars." Drawing from ALMA's millimeter wave data, Loeb crunched the numbers on that deviation. Using momentum conservation, the same physics that keeps a rocket blasting off, he inferred the acceleration implies a massive recoil, specifically about 13 to 20% of 3I/ATLAS's mass, potentially 5 billion tons or more, evaporated, kicking out gas and dust like a natural comet's outgassing. Under conservative assumptions about escape speeds of molecules or particles, that's a sixth of the object's mass gone in a puff. Loeb explained, picture it. Sunlight baking the surface, volatiles sublimating into a jet, propelling the comet like a slow-motion fireworks show. If true, we should see a colossal coma, a glowing cloud of gas, and a tail brighter than a supernova's afterglow when it emerges from behind the sun in early December 2025. But here's the hook that keeps you watching. What if we don't see that cloud? Post-perihelion images from November 5th, 2025, via the Virtual Telescope Project and Arnave's observatory show a compact fuzzy ball. No obvious tail, no massive debris plume. The coma looks eerily similar to Hubble's July 21st snapshot from 277 million miles away. Loeb's take? If it's a natural comet, that mass loss demands a visible fireworks display. No show? Then what propelled it? A spacecraft engine wouldn't belch billions of tons of gas. This echoes Oumuamua's anomaly, where sunlight reflection off a hollow, stainless steel-like surface. Remember that 2020 rocket booster misidentified as Interstellar? Could explain the push without the mess. For 3I/ATLAS, the blue color at perihelion, ninth anomaly on Loeb's list, could be a hot engine or artificial light, not just comet chemistry. And get this. New data from November 4th shows the acceleration dropped by a third, while brightness spiked fivefold in green band filters. The plot twists harder than a sci-fi thriller. To appreciate why this matters, let's zoom out to the interstellar family tree. Oumuamua, Borisov, and now 3I/ATLAS form a trio that tells a story of cosmic diversity and potential design. Oumuamua, young, about 1 billion years old, from the Milky Way's thin disk where stars still birth. Disk-like shape, no coma, subtle acceleration. Loeb's prime suspect for tech, Borisov. Middle child at 1.7 to 3.8 billion years, also thin disk origin, classic comet with tail and volatiles, eccentricity 3.6, a reassuring normal visitor. Then 3I/ATLAS, the elder statesman 4.6 to 9.6 billion years old, hailing from the thick disk's ancient, low metallicity stars, older than our solar system, its eccentricity, a whopping 6.2, vertical excursions dwarfing the others, suggesting billions of years tumbling through the galaxy, gravity assisted by stars and nebulae. Size-wise, it's an outlier, 5+ kilometers diameter versus Oumuamua's 200 meters or Borisov's less than 1 kilometer. Mass, orders of magnitude heavier implying we'd expect thousands of smaller ISOs before spotting this giant. Yet here it is, third in line. These differences aren't just trivia, they challenge models of how interstellar objects form and eject. Simulations by Astor Taylor and Daryl Seligman peg 3I/ATLAS at 3 to 11 billion years, mixed so thoroughly it can't trace back to a parent star. Gemini North's July 2025 images confirmed water ice in its coma at 6.4 astronomical units, hinting at exotic volatiles driving early activity. JWST's NIRSpec observations in August revealed no obvious absorption features, but a redder-than-sun spectrum linear like Oumuamua's. Hubble's November UV spectroscopy hunts sulfur-to-oxygen ratios as it exits. And don't get me started on the jets. A sunward anti-tail in July-August. Complex structures imaged October 10th. Unlike typical dust illusions, the anomalies pile up like cosmic breadcrumbs. 1. Retrograde trajectory aligned within 5 degrees of the ecliptic. 0.2% chance for random. 2. Sunward jet defying geometry. 3. Anomalous mass greater than 33 billion tons from 0 pre-perihelion acceleration. 4. Brightness surge to minus 7.5 power law. 5. Blue shift at perihelion. 6. No pre-perihelion non-graviaxel, despite activity. 7. Post-perihelion, no massive tail. 8. Eccentricity extremes. 9. Blue anomaly again. Loeb's July 17th paper, Is 3I/ATLAS alien technology? In Archivia 2507.12213, argues these scream not natural. In a Joe Rogan podcast, October 28th, he quipped, "It may come to save us or destroy us. We'd better check." Recent Medium posts link it to C/2025 V1, another near-interstellar comet discovered November 3rd, no tail, possible artificial propulsion tie-in. Skeptics like Michio Kaku counter, no aliens until proven. But Loeb fires back, commentary, not calculations. Amid the science, drama unfolds on Earth. The U.S. government shutdown, kicking off early October 2025 over budget rescissions and DOGE cuts, furloughed 15,094 NASA staff while exempting 3,124 for critical ops like ISS and Artemis. It halted data releases, trapping goldmine images from Mars orbiters. On October 2nd to 3rd, as 3I/ATLAS zipped 29 million kilometers from the red planet, NASA's Mars Reconnaissance Orbiter MRO high-rise camera snapped 30 kilometers per pixel side views, 3 times sharper than Hubble's ESA's ExoMars TGO Cassis, caught fuzzy blobs October 3rd. Perseverance's Mastcam Z stacked a faint smudge. China's Tianwen-1 HIRIC released October 3rd images, November 6th. Coma thousands of kilometers wide, animation of Martian sky transit. But NASA's HiRISE, held hostage by shutdown politics. Enter the heroes. Loeb emailed HiRISE PI Alfred McEwen. No reply. Then Congresswoman Anna Paulina Luna, fired up by Loeb's pleas, fired off a letter October 31st to acting NASA admin Sean Duffy. Release the data. Science demands transparency. Duffy ghosted it but tweeted back Kim Kardashian's, "What's the T on 3I/ATLAS query?" Loeb's complaint? Priorities. Congress and scientists first. Shutdown ended November 12th via continuing resolution. Resuming ops. As of November 14th, pressure mounts. Loeb's November 11th, Medium post. 40 days overdue, release now. With IAWN monitoring November 27th to January 27th, 2026. These images could decode mass loss geometry, jets, and composition, ESA's juice eyes at November 2nd and 25th. Rubin and Tess add pre-discovery layers. Why care? Withheld data stalls planning. Will we miss fragments or signals? This isn't just astronomy. It's humanity's mirror interstellar objects like 3I/ATLAS remind us we're not alone in the cosmos. Statistically, billions of Earth-likes out there, ejecting rocks our way at 10 to the 15th to 10 to the 16th per year. Loeb's Galileo project ramps up OSETI with new sites, Breakthrough listen scans, radio whispers. If artificial implications, probes studying us, as we do them natural, insights into exoplanet formation, Oort cloud analogs, volatile delivery to young worlds. Age estimates via backward integrations. Oumuamua's billion-year youth versus 3I/ATLAS's ancient thick disk roots, testing galactic mixing models. As December 19th nears, telescopes train on perigee. Measure outflow velocity, mass flux, composition, natural or tech. Jets could be CO sublimation or thrusters. Blue light, ionized gas or LEDS. No tail post perihelion favors the latter. Loeb's Newsmax, November 8th. Test it. Outflow speeds tell all. Public fascination surges. Letters flood Loeb from kids inspired to stargaze. Global chats on X about gifts from space. Even Kardashian's tweets sparked 10 million impressions, pulling normies into SETI. We've come far since Oumuamua's flyby. Atlas, Rubin, JWST arm us better. But questions linger. Why now? 3 in a decade? Ejection biases or targeted visits? 3I/ATLAS, with its retrograde precision, studies planetary dance like a scout. If engine fired, we're screwed per Loeb's hyperbolic quip, or saved delivering tech. Either way, it's a call to curiosity. So viewer, as 3I/ATLAS fades outbound. Don't blink, December brings plumes or proofs, tails or tech. Subscribe, hit notifications, next update. High rise reveal, juice flyby, your front row seat to history. Remember, in the vast dark, we're all detectives. Stay curious, gaze up, and let's decode the stars together. What do you think? Is it comet or craft? Comment below. Your voice joins the quest.